Hi there, and welcome to another episode of Mr. Carlson's Lab. Today we're going to look at part 2 of the Vedolyzer restoration. If you haven't seen part 1, I'll put the link just below this video in the description, so if you click on the link, it'll take you right to part 1. So let's get started with part 2. In part 1 of the Vedolyzer, we took the chassis apart and removed the vertical section, which leaves the chassis in a pretty bad state. Everything is kind of hanging all over the place, and the structural stability of the chassis itself is really compromised without the face on the unit, because this basically holds everything all together. All the, the VRs and everything are just kind of hanging off the front, and I'll show you that here in just a moment. So really what I want to do at this point is clean the face up, and I want to get this back onto the Vedolyzer with the vertical chassis reinstalled. And that way, when I'm working on it, I can move the chassis around and not really have to worry about a whole bunch of wires breaking off all over the place. Since there really isn't any schematics for this particular version of the Vedolyzer, at least not any that I can find at any rate, I don't want to have to go tracing out broken wires all over the chassis when things get moved around. Again, this thing was put together in 1939, and the wiring, if it's been moved at all, a solid wire, a few moves back and forth and it breaks off, and then of course finding where that wire would go on to, say, a selector switch or something like that could be a very difficult task, especially in this unit. It would take quite a bit of tracing time. So I want to make the structural stability of the chassis solid again, and when it's at that point, I can start working on it. So what I've done now is I've removed the entire face, and I've taken pretty much everything off. I've taken the CRT bezel off and the plastic for the dial face with a lamp on the back here, and I've removed the meter itself from the face, and that'll allow me to clean this. I haven't taken these jacks out here just because I wanted to show you a few things here. So this is the original, I guess you could call it, input jacks for this unit here. It's a really substandard, non-standard, I should say, type of jack, not common at all. So I'm thinking, maybe I could sub these with BNCs, right? Because this thing is not going to be shelf queen. We're going to use this thing to fix modern and antique equipment. Should be kind of fun using something from 1939 to do that. So this is the original connection here. And as you can see, it's not a very friendly type of connection. Center pin in the middle there and everything. So what I found is basically this SO239 will fit in there just fine. It has a little rim. The hole seems to be exactly the same size. It just falls right in. And there are adapters available from SO239 to a BNC connector. Now, the BNC is very common for a lot of test gear today, so I just screw the adapter on, and I could use all my modern probes and everything with this device. So I think this is going to be a good sub, so I'll sub these two with these as well. Nice looking jack as well. So somebody drilled this ground hole out and put a BNC connector in there. I guess this is what they were originally using for the oscilloscope. So this was, put in here like so. And, of course, in order to put this thing in, they had to drill a hole out, and a jack like this really isn't going to fit in this hole. So this is a ground and this is a ground, pretty much the same thing. So what I'm thinking of is maybe trying to find something that'll look the same for both of these ground connections and try and fit another one in. This will just fit in there very loosely because they've drilled the hole out. This thing is going to move around in there. And the way they've put these things on the back side here, as you can see, they've just got these little press tabs on here. So this would slide around, up and down in that hole there. And it'd be a big issue, right? So eventually you'd end up seeing maybe the upper portion, and if you pulled on it, you might actually see the lower portion just because this is drilled out. So I want to put something in here that's going to be very solid. So I'll have to find out, I'll go through all my jacks and stuff and find something that'll look decent in each one of these holes and maybe make it match or something like that, just to clean up the face a little bit. And of course, there's dust and stuff settled on this, and I haven't wiped this thing down at all. So I'm thinking what I'm going to do is probably polish this, maybe put some car polish on after I'm done, touch up some of the black. That's pretty much as far as I can go with this. It's in really good shape. Everything is really solid on here still. Nothing's really been scratched or, to an extreme extent, I should say. You know, nothing's been really damaged on the face. Looks like some corrosion happened underneath the paint here, and some of the paint has come off a little bit there. So I'll just try and touch it up the best that I can, and keep the integrity of the face. You can really tell, like, this is just a blank, and they still have the punch marks. So at the factory, they would line up their punch with these little cross marks there, and you can see that. You see little cross marks here and here. They would punch them there, but for some reason they drilled the holes over here. Maybe there are more punch holes here, different bezel. I really don't know what they were doing at that time. So, and you can tell when they did punch it, they didn't punch all the holes correct. You can see that this one, these are pretty square, and this one's kind of on a slant. So you can tell that the machine is manually operated. Somebody was punching these out. So when you get the thing apart, you get to see all of these, little issues that have, gone on throughout the production and the manufacturing process of this. So even these look a little bit crooked. So this one is definitely tilted. Kind of interesting. So that's what I'm going to do. I'm going to get the face all cleaned up. That'll allow me to get that vertical section back in. And then very quickly, I can also fix up the Wavemeter portion here. We'll take a look at the Wavemeter portion here in just a moment. Another part of the Vedolyzer that has to be rebuilt before I put the face back on is this Wavemeter section. Reason being is when I put the vertical amplifier back into the main chassis, it'll make the main chassis much more rigid at that point. But this sits at the front portion of that vertical chassis. So a portion of that vertical chassis sits underneath this, and then the face would go back on at that point. Now, there's not a whole lot of work to be done in this. There's a bunch of capacitors that have to be changed and a few components that need to be verified, but that's really about it. So these capacitors here just go to this switching network at the front here, and then they ground to the top side of each one of these variable resistors. So each capacitor that corresponds with its adjustment grounds to that adjustment. Now these are just riveted directly to this chassis, so it's just one solid ground. If you were to look at this through direct current eyes, DC eyes, you would think, why wouldn't you just twist all three of these leads together and just solder them to one portion of the chassis? That's the difference between a DC ground and an RF ground. So the RF ground has to tie directly to the adjustment that it corresponds with. So you can see these would correspond, this capacitor would correspond with this, and this capacitor would correspond with this. You'll also see that they took very careful notice of the outside foil. The outside foil layer of each one of these capacitors is attached to ground, and that's the correct way to put these in, because what that does is that shields this entire capacitor right up to this point. Again, the outside foil of the capacitor is attached to the lead where the band end is. You can see the band ends here, outside foil, band ends here, outside foil. So very important in RF application. Again, this is a Wavemeter, so it's a picky little part. So that's what I'm going to do now. So what I'll do is I'll also clean up this little chassis here as well. So I'm not going to take this off of the shaft of this variable capacitor just because this is on here very, very solid. Even with these two screws undone, this doesn't want to budge, so I'm not going to force that off. And I really don't need to at any rate. So if there's any difference in what's reading on the scale, I can most likely adjust that out with these settings on the back here. So to get this off of the upper chassis is really quite easy. Just a bunch of nuts, remove those 4 nuts there, and this whole thing will come off, and I can clean the upper chassis. And that'll also allow me to get into here to these areas as well, so I can desolder the leads from the upper portion of these VRs. What I'll do after that's done is get this all ready to reinstall on top of that vertical chassis, and then when I put the face back on, this switch fastens to the face itself, and a lot of the switches in this Vedolyzer attach directly to the face. That's why there's so many things just kind of flopping around when everything's taken apart. So what I'll do is I'll get the chassis on the bench here, and I'll give you an example of what I mean when I say things are just kind of flopping around. Here's a quick look at the chassis without the vertical amplifier in it and with everything removed. You can see this big square hole in the chassis. Everything's just kind of flopping around here. So you can really see that it needs that face for any kind of structural stability. Everything's just laying all over the place. Lots of wires need to be reattached, and lots of capacitors in here need to be replaced as well. Even on these switches right here, capacitors need to be replaced. You can see all up and down there. and all in here, and they're lined on each side of the Vedolyzer, so there is quite a bit of work to be done. As mentioned earlier, on these resistors, they have sets of resistors with pieces of tape around them. So what they've done is they've basically hand-selected a bunch of resistors. It looks like they've put them in parallel to get the exact value that they needed. So a lot of time was put into this thing to make this thing very, very accurate. So with no ratings on the resistors and just pieces of tape around them, trying to find out if everything is going to work right without it completely reassembled is going to be very, very difficult. So I'll have to put the whole thing back together and try everything out, and anything that's not working correctly, I'll have to trace it back to the components. Again, no schematic for this particular model is available, at least not that I've found at any rate. So that, of course, makes things pretty difficult with this chassis. As you can see, just a lot of work. Everything is loose. This whole section in here, everything is loose. So very important for me to get that vertical section back in and that Wavemeter on the front so I can keep everything nice and sturdy, just because I don't want wires breaking off all over the place. Things are pretty crusty in this unit, built in 1939, right? The Wavemeter is now rebuilt, so I've replaced all 3 capacitors, I've replaced 2 resistors, I've taken the time to clean up the chassis and also clean up the variable capacitor, so I've lubricated the gears and the reduction drive on the front, so now it's as smooth as glass. Now, I really don't want to take any chances with anything in this Wavemeter, just because when this thing's back in the chassis, it's extremely hard to service, and once the face is put back on and everything's put back together, you really can't get in here at all. So everything has been checked and verified with this thing. All the switching has been checked, the VRs are checked, all the resistors that I've installed here, which are these 2, are graded, and I've even checked all the new capacitors as well. Even took the time to install a new neoprene grommet here. The old one was fine. It was a little bit crusty and hard, but it was in perfect condition. I still took it out and replaced it with a newer grommet as well. So this thing is ready for reinstallation. So these are the components that have been removed and replaced. Now, one of the failure points with carbon composition resistors that really isn't talked about a whole lot is the fact that when you overheat them to this extent, what happens is the resistance value goes down instead of up. So what that does is that causes the device that this resistor is attached to draw heavy current and go into what is called a runaway condition, and that causes a lot of damage in the device that the resistor is attached in. So whenever you're working on anything that has a carbon composition resistor that's burnt like this, you really want to check the surrounding circuitry and find out why this thing is burnt like this. Or again, if you're going to design something with a carbon composition resistor, you want to make sure that it falls well within the specs of the resistor, so don't overwork them too much. It's okay to get them warm, but don't get them screaming hot like this one has been. The reason that this one has gone to this extent is most likely because one of these capacitors has been extremely leaky, and there's been some current passed through this thing a little bit more than it would like to have seen. So the resistors on the bottom side here, originally, this is a 40 ohm resistor. This is originally a 400 ohm resistor, and this was originally a 4K ohm resistor, which was this one right here. So the nearest modern value is 390 ohms and 3.9 K ohms, which is absolutely fine. It's close enough for this, and we have adjustments here as well. So if there is any differences or if there's any problem with the dial accuracy, this will be able to adjust that out. Now, another thing that I've done, which is kind of going above and beyond here just a little bit, but when you have a lot of these types of resistors, you can take time and grade them. So I've found a 390 ohm resistor that's actually very close to 400 ohms, and I also found a 3.9 K ohm resistor that's very close to 4K ohms, so it's very close to the factory values. Another resistor that really isn't talked a whole lot about is this type of resistor right here. It looks like a jumper wire with 2 little end caps on it. When these things go bad, if you don't have a schematic, they're a real pain because there's no real coating on them or anything. So this is 40 ohms worth of a little piece of wire here. There's a little resistor in here. So something to keep in mind whenever you see a wire that looks like this with two little end caps, chances are that is a resistor. So when you see a resistor like this that's burnt like this and you're thinking, oh, I'm going to get that, I'm going to replace that resistor before it totally goes bad. If it's to this extent, chances are it is. And if you're going to try and salvage, I guess you could say, salvage a reading off of this resistor and replace it when it's in this state, chances are you're replacing it with a resistor that's going to be too low in value. So I'll give you an example. This is supposed to be 4K ohms. So what I'll do is I'll get my meter in the shot here, hopefully with not too much glaring. Lots of glaring everywhere. There we go. I can get that out of there. And I can see a little bit of the zigzag of the microphone. Maybe that'll overcome that zigzag there. There we go. The shock mount for the microphone. Lots of reflections here. Okay, so again, it's supposed to be 4K ohms. Look at that, 1.8K. So that's really gone down in value. So again, if this was in circuit and you were going to try and salvage a value, get rid of this thing before it, completely went bad and you were to take a reading off this, unless you had a schematic and you knew what the actual resistance value was, you would be replacing this resistor with a resistor of the incorrect value. On the other hand, when you have a resistor like this, that's still in okay condition, this hasn't been overheated or anything, a lot of the times, depending on the atmosphere that they've been sitting in, they go up in value. So this one here has gone up in value. This is supposed to be a 400 ohm resistor, and this uses the body end dot or body end line system. So either bed or bell, you can remember it like that. So the body is yellow, so that's 4. The end is black, which is 0, and the multiplier is brown, so that's 10. So we have 400 ohms. That's how you read these resistors. There is no fourth band on this, so this is a 20% tolerance resistor. So since this is supposed to be 400 ohms, I wanted to get rid of this because this is reading about 500 ohms or very close to. Now, this can be a little bit deceiving as well because the color of the band here really isn't a true brown. It's kind of a brown verging a purplish kind of color. You can maybe see that on camera. So again, that can be deceiving as well, depending on how you look at it. It looks a little bit more purple here than it does here. So things to keep in mind when you're working on this. So sometimes when you don't have the proper literature or schematics for these things, a little bit of thought is involved in replacing these things. So this would definitely not be a 4K ohm resistor or anything like that. And of course, if the the multiplier band is purple, it would be way, way, way up there in resistance, which just wouldn't be in a circuit like this. So, this isn't a red and it isn't a purple or anything like that. It's definitely supposed to be a brown color. So things that can kind of catch you if you're new working with things like this. Another thing, if you're new with working with, things like this and you find wax capacitors in anything, they're always bad at this point. Wax capacitors like this, they have a wax coating on the top side of them. They are always faulty, so you never leave wax capacitors behind. If you do, you're setting yourself up for a future failure. All wax capacitors are out of there. The Vedolyzer is coming back together. As you can see, I've installed new jacks on the bottom here so I can use modern probes with this. I've also installed those SO239s. Again, this thing isn't going to be a shelf queen. This is going to be actively used, so I want to be able to easily use all of my test leads and probes with this. Spent a lot of time cleaning up all the little Bakelite knobs and buttons on here. Cleaned up the face. So I used a very, very mild abrasive on the face, cleaned up the face, and then I used some automotive wax, and it turned out really, really well. Lots and lots of time in that alone. So all new stainless hardware I'm using on the face here to hold everything in place. So what I need to do now is get onto the underside of the chassis and fix a lot of the issues under here. Lots and lots of capacitors to change. And one capacitor has really exploded and it's basically shot all of its innards all over these coils down here and everything. So what I'm going to do is I'm going to reposition the camera and I'll get you closer in and I'll show you exactly what that capacitor's done and what I'm going to tackle next on this. Taking a closer look at the bottom portion of the chassis, we can see that there's a yellow substance that's been sprayed all over this little sub-chassis, all over these coils. We can see that there's some debris here that's fallen off of this wall, and that yellow spray is also all over this wall here. Well, what's happened is this capacitor right here has been extremely hot and it's vented on this side right here, right where the lead exits the capacitor. There's a little small pinhole there. So it's been hot and it's sprayed its internals all over this whole area here. Now the stuff has been sitting on these coils for a long period of time and on this wall here on the metal. And the metal underneath the material is very, very nice. It hasn't rusted or damaged it or anything. So what that tells me is it's just most likely hot wax that's sprayed out of the capacitor, which is nice because if it was, some form of electrolyte or anything like that, it would have probably damaged all of these coils by now. And these are the coils for the Wavemeter, so if these were damaged, the Wavemeter wouldn't work correctly. So I'll spend the time and clean this little area up, get rid of all of this wax here, and very carefully clean these coils off. I have to be very careful not to damage these very fragile little wires. So I've got the vertical section all put back in here, but I haven't wired a lot of it up just because these wires here have to go through this little wall and through these grommets right here. I don't know if you can see those little grommets. Yep, I haven't replaced these. These are still the original ones. So they're in really nice condition, but I have new grommets I'll end up putting in that wall at any rate. I'll feed these wires through. These wires here attached to this little sub-chassis that fits in here like this. So everything has to be rebuilt in order. This capacitor here will get changed as well. This is an electrolytic capacitor that somebody's added in at a later date. I'll verify these resistors while I'm down here because once I put the sub-chassis in, I really don't want to take it out again. So I have to replace all the capacitors and test all the resistors down here. And on the upper portion of the chassis here, we'll take a look at that. I have to replace all these capacitors up here and this capacitor here as well. I see somebody's installed a VR on the back side of this one. Now, I don't know if that's factory or not. They may have done that at the factory, kind of as a fine tune or something like that. Kind of interesting, but there's a VR soldered on the back side of this one right here. Maybe they tried to make things more accurate. I haven't reattached any of the wires to the jacks yet. I'll have to do all that. I've reattached a lot of the wiring in here, not in the vertical section, but a lot of the wiring after I've removed the face and everything like that. Again, it's a really good idea to take lots of pictures before you take an entire unit like this apart. There's lots and lots of wires that I had to reattach. And of course, the longer that you leave them, if you say you're fresh into the project and say you get sidetracked and you start working on another project, if you leave those wires unattached for a long period of time, you don't have pictures or anything to reference, the unit itself. Finding where those wires can go when you don't have a schematic can sometimes be a real pain, and it really elongate the restoration process is what it does. So lots and lots of pictures from every angle, because you'll find that you'll take pictures and you'll have 5 different angles, but the angle you needed was the one that you didn't take. So take lots and lots of pictures. It doesn't hurt, and if it uses up a lot of space when you're done the project, you can delete a lot of those pictures. So it's definitely worth it in the long run. I haven't replaced this wire yet. Somebody had installed that into that BNC that was, installed in this area up here. So this I'll put back to this jack here, and this will just return to a ground. So still quite a bit of work ahead of me. I haven't put the shield in here yet with the batteries, the bias batteries. I managed to find some really nice batteries that have an old look to them, and I'll show you those batteries here in just a bit. So the ones on the bottom here are C cells, and the ones on the upper portion of the chassis are D cells for the VTVM circuit. So I have to replace those batteries as well. And after that, reconnecting the wires and stuff, the thing is just about ready to try out. I'll put the CRT in it, and hopefully that CRT is okay. So this has been such a long process. Getting to the point to saying almost ready to try out seems almost too good to be true at this point. I hope you've enjoyed part 2 of the Vedolyzer restoration. It sure has been quite the process to get to this point. I can't even tell you the amount of hours I've put into this thing so far. I'm hoping in part 3 the restoration will be complete and we can start using this very neat piece of test gear to troubleshoot and repair other pieces of electronics, modern and antique alike. So it should be a lot of fun to, say, take a modern switch mode power supply and fix it with a piece of gear from 1939. Definitely a lot of fun. If you've enjoyed this video, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos coming like this in the near future. We'll be taking a look at vacuum tube and solid state electronics alike. So there'll be a lot of repairs, designs, restoration, troubleshooting, all sorts of neat stuff coming on this channel. So if you haven't subscribed, now would be a good time to do that as well. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, you may want to check out my ongoing electronics course on Patreon. I'll put the link just below this video at the top of the comments section. It'll be pinned there. If you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.